Okay, here's the alternate approach for the testing station for the MPS system, and here we're using a sequencer to try to get it through, and we just sequence between different states. And if we take a look at our state diagram again, here's what we're doing when we go through the different states. We clear the equipment zone, we go up, and we go up till we go to the measuring device, and then if we're valid, we go through this path. If we're defective, we go through this path, and then we go back to home. And so what we do is we kind of have this final timing diagram where we have these states and we detect something, and then that sets off a timer. Timer's done, we get the done bit, that sets off the up bit, and so on. And we keep rumbling through in sequence through the state machine. Now over here is the states that we have. This is state 1, state 2, and what we do in each state. And here's the values that we're actually putting in the sequencer. It's an output sequencer, so these are the values that are getting shifted into the output sequencer. And if we look at what we have for that table, this is just a table for what steps we go through when we have a valid part. And when we see a 1, these are the steps we take. And defective parts, these are the steps we take. And all the steps are the same except these last 3, and they're out of sequence. Valid part, we just put it onto the air slide, whereas if it's defective, we go back down to the bad track slide and then drop it off. And we're going to put in motion, but when we go through the sequencer, it's really complicated because unlike a counter or something where we use the same circuit to advance the thing, the sequencer, we have, if our object is detected, then we move if we clear the equipment zone, then if we hit the up limit, and that has to be a strobe since we are just looking at pulses. So it's a little more complicated. Here's our sequencer. This is the valid part. This is the defective part. And we have timers in here, and they're very much exaggerated so we can watch what's going on. But if we look at our tables out here, these are the binary tables. Table 2 is defective part, and table 10 is the valid part. And so what we'll do is we're going to put the register right next to the sequencer. So you can take a look at the values of the register. We're going to take a look at this register here is the one for the defective part, and then we can watch the steps that goes through in the sequencer. And again, remember that these time delays are very exaggerated, so you can look at the different steps. So here we're going to put defective part in there. It's moving up, it's making the measurement. Now it's moving down, and it's going through the process of putting it onto the bad track, and now it's just waiting for the end of the cycle. When it goes all to zeros, it'll be end of cycle. And there, it's the end of the cycle. Now when we put a valid part on, that's this register here, register 10, and we can see again the different steps over here, and then the different bits that are switching over here. And our parts in, it's going up. It's making measurements, and now it's activating the control valve, and now it's just waiting till we complete, and when we're finished it'll go back to all zeros, and there we have it, and we're back at step 1, and that's the way the sequencer works. Now we're going to move over and actually watch it in action, and it doesn't run that well. There's still some bugs in the system, so you'll have to bear that in mind if you when you try this. But it's a good concept. You should try to do it with the sequencers. And so we're going to put the defective part in. Runs up, makes the measurement, runs back down, and then pushes it on the bad track. And it just waits for the end of the sequence, and then it'll be ready for a new part. And they're timed out for the end of sequence. Now we're going to put a valid part in. So we put the valid part in. It delays for the measurement. Here's where it doesn't really work that well because it doesn't push it on the track at the right point. And here we're just waiting for the timeout for the end of sequence. Until it times out, you can't do anything. And here's again with the defective part once again. Goes up, measures it, it's faulty, comes back down, and then it'll push it on the bad track. And that's a video for what the sequencer is.